Now that we have a really good understanding of the movement path, of the motion path of our ball as it takes our jump, let's figure out the timing, the speed in which this animation is going to take place. At the moment, we have a really good idea of how it's going to look and feel in my imagination, but I need to start prototyping and blueprinting the speed. And these little timing charts do a great job of us very quickly getting to that end result. If you think about it, the art of animation is incredibly laborious. We're going to be animating and drawing a ball, squashing, jumping, and then landing again. I want to be able to have a really good understanding of how many drawings I need to make and where their timing or how their timing is going to influence the audience's understanding of this illusion. So these timing charts are a really fast way of doing this. And it's a great tool to help us visualize the speed of the movement. I'm going to be placing my timing chart kind of at the bottom down here. Think of these timing charts kind of like a ruler for time. It's going to show us quite wonderfully in an animated form how all of these little how we envision this animation going to move. It's not going to determine and depict the actual movement, but the speed of the movement. We're trying to figure out the speed. Imagine for a second that you're drawing a character like Mickey Mouse jumping. Well, how fast is Mickey going to jump? The answer to that question is going to determine how many drawings you need to make. It's good to make that determination now and get the answer to that question in a simple ruler, a simple chart, than having to explore the timing in a detailed drawing of Mickey Mouse. Let's go ahead and start the process of making one. You can put these timing charts anywhere. I like putting them roughly at the bottom, underneath the movement path, if possible, of the object that we're trying to make. And remember, this is supposed to be just a very, very simple ruler. We're not trying to showcase and depict the actual movement, but the speed of the movement. I know that the speed of the movement is going to be represented by a first frame and the last frame. Every animation is going to have its last frame. But when is the first frame? Well, when the first frame is going to be frame 1. But when is the last frame? I don't know. The timing chart is going to help us figure that out. Let's go ahead and make one real fast. We're going to start by going into our grease pencil object, and I'm going to add a new layer. And as one might imagine, we'll just call this timing. You can also call it timing chart. I want to ensure that all of this information is being placed on its own dedicated layer so I don't accidentally mess up anything else, and I can turn it on and off as I go throughout the system. In addition, let's create 2 new materials. I think I want to call one black. There we go. And it's just going to be a simple stroke. And then I'm going to have another one. And I think I want to have this second material be like a yellow. All right. Let's give it a good color. Excuse me. Maybe, I don't know, something real bright, something really easy for everyone to see. Somewhere right around there. Yeah, I'm liking that. Okay. So now on the timing layer, let's go into draw mode, and I'm simply going to use the line tool to flush out this little graph. If you hold down the shift key, it's going to constrain your lines to a horizontal or vertical axis. The first thing that I'm going to do here is draw a big horizontal line, and I accidentally drew it with the yellow material. I wanted the black. So let's go back into our materials, change our mode to edit mode, and select the stroke that represents that horizontal line and reassign it to the black material. There we go. Just that easy. Now, let's return to draw mode one more time, and we're going to create another line. This one's going to be a vertical line. This vertical line here is going to represent, kind of our playhead. Okay. And we're going to be animating this going left and right within inside of the frame itself. Happy with that? Hit the return key to commit that in. And the rest of our work here is going to be done in edit mode. As a reminder, what we are trying to accomplish here is an understanding of time and speed. So let's start prototyping this. So this is when the ball is going to begin. And of course, it's going to end its animation over here. But when is it going to end its animation? This is where we kind of need to pretend and project. I need to be able to see the movement in my mind's eye before I can start blocking at its timing. Let's just initially put it at frame 30. So I've moved my playhead to frame 30. There we go. Let's move it up so we can see. I've moved my playhead to frame 30. Now I move my bar. I'm going to grab it with the G key, hit the X key to constrain it to that axis. I'll put it right down over there. Wonderful. So now on frame 1, the bar is on that side. And then on frame 30, boom, it's on that side. Okay, so we figured out when the ball is going to start and when the ball is going to end its animation, but when is it going to be in the middle of its animation, when it reaches the apex of the curve? Because in my imagination, what's going to happen here is the ball is going to squash and stretch. So it's squash down, it's going to jump up. And then as it gets to the top of the arc, it's going to slow down. Because at the top of the arc, gravity is going to be pulling down on it the most. So it's going to slow. So it's going to go slow here, and then fast, and then slow down at the end as it squashes back down on the ground. So in the middle of the animation, let's just say arbitrarily at frame 15, this is when I want to have the ball at its peak, way up here. Okay, so let's grab our line. And I'm going to put this line in the middle or so of my animation. So squash, apex, land. Squash, apex, land. I've changed the duration of my timeline to 40 frames. That way I can loop this as often as I can. I like being able to work in this really organic fashion where I throw down some keyframes and play it instantly. If the animation doesn't jive with what I'm seeing in my imagination at this stage, it's never going to work at a later stage. So it kind of still needs, I need to be able to see it in here in order for me to really get it. Now I know that on the surface, the animation needs to slow as it gets to the apex. So this might be a good place to kind of begin to construct the timing of our animation. In order for me to get a real good sense that it's slowing down, I think I'm going to need probably 3 frames on either side of the apex of my curve to really communicate that slowing and then coming back down. So if this is where the ball is going to be on frame 15, okay, on frame 14, maybe we tighten the spacing. This is just a visualization of this. So we have maybe there's 2, grab X. So now it's starting to slow down. I'm going to go into my object data properties, this green icon, and change the onion skinning values to like 5 after or 6 after. That way I can see all of the future frames. I'm seeing both 12, 13, 14, and 15 at the moment, which I like. Okay, so let's see if this is the apex. Maybe one more, maybe on frame 11, grab X, and starting to slow down. Now, if you look at the distribution here, look at the onion skinning. I think this is really going to help. We can see where the ball is going to be on frame 11. As it gets closer to the apex, the spacing in between these ruler markers gets a little bit tighter, which is going to represent the idea that it's starting to slow down. All right, I'm liking that. That's pretty good. Let's play it. Yeah, I'm digging that. Let's do the exact same thing on the other side of the apex of our curve. So 11, 12, 13, 14, 15. So we have 4 frames that describe the slowing as it goes into the apex at frame 15. So now let's do the exact same thing. Grab X. It's going to move very little in here. On frame 16, grab X. Okay, I'm going to go back to my object data properties. And the keyframes before, I'm going to increase this to 6. I'm also going to turn off the visibility of my background layer just to make it a little bit easier to see all of my frames. Yeah, I think I went a little too far on frame 17. Grab X. And this really kind of speaks to the power of this process, is that we can prototype very quickly. All right, so here's frame 15. I have 4 frames after. And if you look at the total spacing here, this is the part of the movement where it's going up. It hits the apex on the yellow line frame, and then it goes down. I'm looking at the spacing here. Yeah, and it's pretty close. I'm digging this. Let's play it. Always play your animations. Yeah, and I'm liking that. With the apex established, we can get a really good solid understanding of how it's going to slow and then come back down. We also get a really good understanding of how many frames it's going to take to go up, because we need to squash and stretch in here. So from like 1 to, I don't know, 7 or so, it's going to squash and stretch. And then we have a couple frames where it's going to move very fast. Let's kind of dial that in right now, so we have a really good, solid understanding of what this is going to look like. So in frame 2, I know it's going to squash, maybe 6 frames to squash or 7 frames to squash, and then jump up. Okay, let's go to frame 2. Grab X. It's going to move very slowly at first. So I'm going to keep the spacing of these little ruler markers pretty small. Okay, frame 4, grab X. This is where it starts to move a little faster. Frame 5, grab X. Frame 6, grab X. You can see the kind of the process here. Goes very quick. All right. We've established the squash and stretch range of frames. Yeah. Squash, boom. Squash, boom. Squash, boom. Yeah, I'm liking that. Now, in order for us to get to frame 7 to, what is that? That is 11. If you look at the way the onion skinning is communicating, here's frame 7. This is where the ball would be roughly in our representation of frame 7. It makes quite a jump between frame 7 and frame 11. I think I'm going to try to evenly space out frame 7 and 11. Let's do it real fast. Let's go to frame 9 and maybe put it right here in the middle. Go. Frame 10. And then frame 8. Yeah. Cool. Now, if you look at the way that all this is working out, apologies, let me go back into my camera's viewfinder. If you look at the way that all this is working out, you can actually kind of start to visualize the squash here. All the ruler markers are pretty closely, tightly together. Where it spaces out, the ball is going to be moving upwards, and it slows down as it reaches the apex of its arc right over here. Let's play the animation and see what we get. Squash, stretch. Yeah, I'm digging that. This is a great, great illustration of the first part of the timing chart. I'm going to do the exact same thing on the back side real fast. And so we can just kind of lock down and just really figure out the timing of the back part of our animation. Okay, I'm going to reverse engineer it. I'm going to work backwards in time. Instead of working at the apex, I'm going to work over here at the where I know that I'm going to need some frames to slowly kind of resolve the movement. So let's go to frame 29. Grab X. Hopefully by now you're starting to see pattern here. Grab X. And luckily for us, this just takes a second to do. But it gives us so much information. I'm going to go right in here real fast. I'm going to adjust the timing of these frames just ever so slightly. That way it's really starting to slow down. There we go. So 19 to 25. Yeah, so this is where it's really falling in this point. So let's go, let's split the difference maybe here on 22. Kind of put it in the middle. And that way, on frame 23 and 24, we can evenly space out all of this. Because when it's going fast, it should be moving generally kind of even. You can see that. I can make some adjustments to this. I can noodle with this all day long, by the way. And animators are renowned for doing that, just to make the timing just absolutely perfect. But this is a really great approximation of the timing of this ball jump. Let's play it. Yeah, there it is. That's the timing of our animation. It starts slowly as it squashes. It jumps up. It's going to move fast. As it gets to the apex, it's going to slow and then come down. Yeah, I'm loving that. If I zoom out a little bit here, yeah, I'm projecting. I'm pretending that there's a ball here. Squash, boom, squash, boom, jump, jump, boom, jump, boom. And I've done all of this in just a couple minutes. I've done the hard part. Now I can actually go in and draw the ball, match the timing to the timing chart that I've created, and very efficiently work through the creation of our jump. I don't have to worry about the timing in the next stage. I have to worry about the squash and stretch, the individual poses that's going to bring my character to life. The timing's done. I'm done with this. If I wanted to, I'm not going to, but I certainly could go in and tweak all this ever so slightly. Yeah, I'm not going to tweak it. I think I'm happy with it. This is an easy thing to tweak because we're just animating a bar going left and right. We're not animating too much more on top of that. If I was to make a change to the finished final drawing of Mickey Mouse, that would be very laborious. It would take a long time. These timing charts are great tools for us to very quickly get to the answer of how fast our movements are going to take.